Hello. In this episode, we'll see this frozen example we have seen and see how it's being implemented in Keras using the Q-table method. Okay? And in general, to remind you, the frozen game was that we have 16 tiles starting here and ending in the goal. And we want to go to this goal by moving left, down, right, up, only stepping on the frozen, not the holes. Okay, so and we're gonna do the reinforcement learning, which is each state you see, we decide an action, and then the environment, which is beyond our control, will give a reward and move to the next state, and we play this game over and over again. Okay. And to implement in the code is that we make an array of 16 elements. Okay, and put the Q values in here. Since we have 4 moves, there will be 4 Q values stored. And each state, the highest Q value will be the action that is chosen. So let's see how that is implemented. Okay. So we'll use NumPy and Math. It's a simple program. First, if you have access to, you can import the OpenAI database, the Atari game package. But if you don't, here is a code that I coded. Okay, so this is the frozen environment. What that is that we need, based on our reinforcement learning algorithm, and we choose an action and for a given state, we need the response from the system. It's called environment. So let's first create the environment. We have 4 rows and 4 columns. There are 4x4 tile in this game. Okay. And the row and columns come from the number, and we have to convert from the S, which is from 0 to 15. There are 16 tiles and number 0 to 15. Okay. And compute from that S, the tile number in the array, into row and columns. Okay, we convert. All right. So next is the state S1, so row here. So if we choose A0, 1, 2, 3, so these are the action choices. 0 is moving left, 1 is down, 2 is right, 3 is up. And then we change the column or row numbers accordingly. So left means that you increase the column, okay? Decrease the column moving left. Right is A2, we increase the column unless you have at the very left end of the boundary, then you cannot, of course. So you cannot go below 0, or you cannot go, if you move right, you cannot go beyond 3, isn't it? Right. And down and up again. So if you go down, you increase the row number. If you go up, you decrease the row number until you hit the boundary 0, 3. The reward is when you reach the goal, you get 1. So it's the RC equals 0 unless it's tile 15. And you end the game, you decease when you reach the goal or are in one of the holes, which are the tile numbers. S5 is 1, 2, 0, 1, 2, 3, 4, 5. So this is a hole. 6, 7 is a hole, isn't it? And then 11 is a hole. Yeah, and 12 is a hole. So this is the environment. So you return, so whenever it takes an input of the current state where you're in the tile and an action, and based on it, it gets a reward and the next state and whether you're deceased, and this information is turned back in. So this is the environment. Okay? And then you initialize the parameters. There are 16 states and 4 action choices, and you have a Q value of 16 by 4 array. The learning rate we give 85% and time discounting of in the Q learning 2.99, and we'll play 300 episodes. Okay, so let's see how the simulation works out. So I will accumulate the reward list. You don't have to. And then the number of episodes, 300 episodes. We play the game over and over again. S starts with 0. You always start in the first tile. And then R all is 0 right now. You didn't die. And your current step is 0. So while the number of steps are less than 99 steps, if we pass more than 99 steps, which is very long, many steps, then end the game. Or if t is 0, when you die and step on a tile or end the game, you end. Action is look at the tiles. Okay, look at the tiles. Choose an action greedily by with noise of picking from the queue table. It's the maximum argument of the queue plus a random number from the number of actions divided by 1. So basically choose the largest queue value action. Okay, and you could add some noise and sometimes randomly pick a different action. Okay, so now you choose an action and use that as tile. So S is, that's in the beginning it's 0, but later it will be 1, 2, 3 or some different number. A is the action. Based on that, your environment will get your reward and the next tile and whether you died or not. Isn't it? And then based on that, you do the Q learning. Remember the old Q value plus learning rate times reward plus time discounting of the maximum next step, next tile's Q values among the largest, and compare it against the current QSA value. Okay, if that is positive, then increase the Q. If it's negative, decrease the Q. Okay. And then accumulate the R. We just want to keep the history of it. The next tile is now the current tile, then the number of plays you played, and keep playing over and over again for 300 games. Okay. So it runs really fast. It's already done. And it goes 6 steps. It ended up in tile 15, reached the end, and you got the reward 1. So, okay, so that was not initially the case. You can see in the beginning, it didn't reach the goal. It didn't get reward, but once in a while, by some trying, it did. And after a while, it figured it out when you can get the 1 here. And after a while, it actually fully learns how to get this. Right? So the result is here, for example, at tile 0, left, down, right, up. For the first tile, you better go down, isn't it? So for example, this correctly gets it. And you can keep checking the tile 1, the 4 actions, tile 2, 3, 4, tile 15, 4 actions. And you can see that the largest value is where the desirable action. So this is to show how to implement Frozen for reinforcement learning. Thank you for watching this episode.